Hello and welcome to Statecraft IAS Academy. I'm Atif, your geography educator, and today we are going to discuss something very important. Monsoon in India. Monsoon is very important since India is predominantly a country that's dependent on agriculture. More than 50% of people rely on primary sector. And monsoon plays a very important role in helping us maintain our agricultural production. But this year, when we take a look at monsoon, we saw a bumpy start. There was a slight delay in the onset of monsoon. Normally, the monsoon starts a few days earlier as compared to what it was today. But the thing is, why was there a delayed start? Why was there delay in monsoon? And more important, how exactly do we determine that the monsoon has actually arrived? What are the criteria that help us determine the arrival of monsoon? In other words, there is rainfall throughout the month of May, but we call them pre-monsoon showers. We don't call them monsoon. So what is the difference? Why is one rain called as a pre-monsoon shower and the other as monsoon? Is there some criteria? Yes, there are three criteria that need to be met in order to classify the rainfall as monsoon rain. And this year we saw a delay on the arrival of these three criteria. What was the factor that caused this delay? Well, monsoon is something that's caused by multiple factors. There are a lot of factors that determine the onset, the arrival of monsoon. For those things, you need to go through today's lecture. You will understand all the things that are essential for monsoon. And then we will link those things with this thing. That's the delay of monsoon. Well, let's start with normally what a monsoon is. All of us know that monsoon is seasonal reversal of winds derived from an Arabic word meaning motion. Okay, but there are two types of monsoon. One is the southwest monsoon and the other northeast monsoon. And these are the two kinds of monsoon that normally determine the seasonal reversal. How? Take a look at this very map. First of all, before we go ahead into the theory, look at this map. You can see the wind direction like this, or we can see the winds coming from southwestern direction, coming towards India over massive water bodies, Indian Ocean, Arabian Sea, Bay of Bengal, and then they hit the Indian landmass. Because the winds come from the water bodies, they bring along with them moisture that leads to rainfall in India. And this type of monsoon, this type of rainfall is called southwest monsoon or the season of advancing monsoon. At the same time, when we talk of the month of October, we can see there is a reversal in the direction of winds. The winds that earlier used to blow from southwestern direction now are coming from northeast. And these are usually dry because they do not come from a water body but from landmass. However, there are some exceptions, like along the Coromandel coast we can see rainfall. Well, we will discuss that when we will talk of the winter rains in India. Right now, our concern is southwest monsoon. That brings me back to my question. Okay, the winds coming from southwestern direction bring rainfalls in India. But there are winds that are coming from this direction in the month of May as well. So why don't we say in the month of May that that's a monsoon shower? Why we say that this is a pre-monsoon shower? There are three criteria that determine the rainfall as monsoon rainfall. What are the three criteria? Number one, rainfall requirement. What's that? We have a total of around 14 stations in South India. You can see them along the coasts of Kerala, Karnataka, Tamil Nadu, in Andaman, in the Lakshadweep. We have a total of 14 stations. So first criteria that needs to be met is out of the 14 there should be at least 60% of the stations that should receive rainfall of more than 2.5 millimeters, but that too for consecutively 2 days. What is the first criteria for a rainfall to be classified as monsoon? Out of all the stations, there should be at least 60% of the stations on which we have a rainfall of 2.5 millimeters for 2 consecutive days. What does that mean? It means the rainfall should happen today and tomorrow. It's not that today we have some rain, then there is a break of 1 day, then after 2 days we will have further rain, and then we will say, okay, we have 2.5 mm. No, it should take place in 2 consecutive days without any break. That is the first criteria that needs to be taken care of while determining whether it's a monsoon rain or a normal rain. What is the second criteria? Wind. The westerly winds. How? Listen to me. The wind at 600 hectopascals. Listen to me first. 1 HPA is equivalent to 1 millibar. Okay? Remember this. When we talk of ground level or sea level, what is the pressure at sea level? 1013.2 MB. This is the pressure at sea level. For a rainfall to be classified as monsoon rain, we want consistent winds, persistent winds at a pressure of 600 HPA. I told you 600 HPA, or you can say 600 millibars. If we have a pressure of 1013 MB at sea level, as we start to go higher, the pressure will start to decrease. After traveling, let's say around 2 to 3 kilometers, there will be a pressure of around 600 millibars. At this very location, at this very point, there should be persistent westerly wind. There should be persistent westerly wind. Only then we can say that this is something that is important for monsoon. And one more thing that you need to remember is at a height of where we have a pressure of 925, there the speed of wind should be around 20 knots. What's 20 knots? Let's understand it as around 27 to 30 kilometers. These are the criteria for the wind speed. Are you getting my point? What? First criteria. Rainfall, 2.5 mm of rainfall for 60% of the stations or consecutively 2 days. Second, there should be constant, persistent wind at 600 HPA and a wind speed of 20 knots at 925 HPA. So we have done with 2 criteria. Now the third and the last one, that is outgoing long wave radiations. Outgoing long wave radiations. Outgoing long wave radiations must be less than 200 watts per meter square. What does that indicate? Listen to me very carefully. Let me clear this first. Listen to me very, very carefully. Let's suppose this is sun. Okay? It emits radiations that are short wave. So solar radiations are short wave. They come, hit the surface of Earth and heat up the Earth. Once the Earth heats up, it starts to radiate back radiations, but they are long wave radiations, not short wave. For the monsoon, we want only 200 watts or less per meter square. How is that possible? It's possible if there is a very solid cloud cover which does not allow this radiation to escape, because the satellites that are located over or above the clouds will only detect that much of radiation that is coming out of these clouds. But since the cloud cover is very dense, it will not allow this radiation and it will radiate it back towards ground. only a little bit might go out, but we have to check whether we are getting a radiation of less than 200 watts per meter square. If that is the case, then we say that the rain that is taking place is monsoon. Long story short, I'm going to summarize it for you. There are three criteria primarily. Number one, a rainfall of 2.5 millimeters for 2 consecutive days. Number one. Number two, there should be persistent wind 600 HPA. And number three, there should be less than or equal to 200 watts per meter square of outgoing long wave radiation. When these three criteria are met at once, simultaneously, then the rainfall is considered as monsoon. And this condition in the year 2026 was observed on 4th of June 2026, of course, which showed a slight delay from the normal date of arrival of monsoon. Now the condition here is satisfied, but why was there the delay? There are multiple factors. For that thing, you need to understand what are the factors responsible for monsoon. Monsoon is a very complex phenomenon. It's not a simple rain that we think. No. You can see it's mentioned in Rig Veda as well. However, the Arab traders used these monsoon winds for trade. They used to travel to India along with the southwestern monsoon. They used to come to India, and then when they left India, they used again the northeastern winds. So they understood the pattern of winds. But the actual discovery, actual research that led to its explanation was started by Sir Edmund Halley. So the first theory that we're going to talk of is Sir Edmund Halley's theory. Well, of course, this theory was not complete, but it was a start nonetheless. What did he say? He simply suggested that the monsoon is a land breeze and a sea breeze. What is the meaning of that? Remember this thing. There is a property of land that it heats up quickly as compared to water, and it cools down quickly as compared to water. It heats up quickly, it cools down quickly. So what happens during summers? During summers, when there is intense solar radiation on land, it heats up more quickly as compared to water. Now, since the land is hot, we learned it in the very first lecture. Whenever the land heats up, the air starts to rise. When the air rises, we get a condition of low pressure system on the ground. And low pressure attracts winds from all directions. Am I right? Any confusion? These winds are attracted by this low pressure system, and we have surrounding water bodies, Arabian Sea, Indian Ocean, Bay of Bengal. These are water bodies, so the air coming from these areas will be moist, and because of that moisture, it causes rainfall in India. Simple. Land heats up quickly, low pressure develops, it attracts winds from the oceans, and that causes rainfall. And during the October season, when the sun shifts towards the southern hemisphere, we can see the land cools more quickly, a high pressure system develops, and the winds start to blow from land towards water. This was the concept of Edmund Halley. Simple concept, nothing too complex or something, but there were certain drawbacks because the concept was very simple. There were drawbacks. What were the drawbacks? Why is there sudden burst of monsoon? Why is there delay in the monsoon? Like we witnessed it this year as well. There was a delay in the monsoon. But why? This thing was not explained by Sir Edmund Halley. Subsequent theories developed. One by one we will see and how each and every theory explains things. The next theory we are going to discuss of is air mass concept. And the pioneer of this theory is known as Flohan. He gave the concept of air mass. Now, before I start to explain you what's the concept of air mass and ITCZ and other things, if you remember, in my first class, I explained to you the pressure belts. If you remember, this is Earth. I explained you in very much detail how the pressure belts are located on Earth. When the sun shines over the equator, what happens? The air heats up. It attracts winds from all the direction. These were called as easterlies. If you remember properly, these are the easterlies. Okay? But there is one twist. Listen to me. Listen to me very, very carefully. These are the pressure belts that we already learned about. Okay? If you remember, this is the equatorial low pressure belt, or we called it as the Halley cell. Then we had Ferrel cell. And finally, we had polar cell. My question to you, we talk of sun. Okay? Whenever sun was on equator, it would heat up this area and the air would rise. So we developed low pressure conditions here. When the low pressure conditions developed, it attracted winds from all the directions. Am I right? Now there is one more condition. When it's summer and the sun is not overhead on the equator, it is somewhere else. It is located on the Tropic of Cancer, somewhere here. Here. Don't you think when the sun will be here, low pressure conditions should ideally develop here? Because the air will start to rise here. Right? So the winds that were getting attracted at 0 degree will now get attracted at this point. There will be a shift. There will be a shift in the pressure belts. Yes, that's true. There will be a slight shift in the pressure belts. We can see there will be a slight shift in the pressure belt, and we see at 30 degrees, we will get low pressure system instead of 0 degree. 0 degree, we won't have low pressure as compared to 30 degree because the sun is here, the land is heating up here, and that will lead to the coming of winds at 30 degrees. The winds will start to get attracted at 30 degrees instead of 0. And that is exactly what we know as intertropical convergence zone. What is intertropical convergence zone? It is a zone of convergence where the winds converge. When we talk of Earth, at equator, most of the times, the winds converge like these, easterlies, remember? But what happens when we have sun over the Tropic of Cancer? This ITCZ, instead of being at 0 degree, shifts slightly northwards. It shifts slightly northwards, right? It shifts northwards, and there the winds will start to converge. Now take a look at this image, this one. This is the normal condition, and this is the shift during the northern summers when the sun shines at this location. This heats up, and the zone of convergence is somewhere here. The winds will start to converge at this point. Are you getting my point? The winds will start to converge at this point. Now, there is one more twist. This is the equator. The winds will start to come from southern hemisphere like this. This is the direction. Why? Because of the Coriolis force, of course. Coriolis force, when we talk of Coriolis force, it turns everything to the left in the southern hemisphere. What will the condition of the winds be once they cross the equator? Now, instead of moving left, they will start to move right. Why? Because in the northern hemisphere, the winds are turned to right instead of left. So you see the direction will be somewhat like this. Like this. Initially left when they are in the southern hemisphere, and then once they cross the equator, they will turn right. Why will they turn right? Because after you cross the equator in the northern hemisphere, everything is turned right. Now look at this very diagram. The winds, these small arrows, the winds are coming like this. But this is the equator. Once they cross the equator, they go like this. And these start to bring rains towards India. This was the concept of Flohan. That's what he mentioned. As the sun shifts northward in the summer, the ITCZ, or the intertropical convergence zone, where the winds will converge, it will also migrate. It also migrates towards Ganga plains. That pulls the southeast trade winds from southern hemisphere. That's what I was mentioning you. So this is the concept of ITCZ, where this is the region where the winds will start to converge. From north as well as from south. The winds coming south of the equator will move first left. Once they cross the equator, the direction will change towards right and they will strike India and bring rainfall. This was the concept of Flohan as air mass theory. Although it still did not consider many things, but it explained a few things, like why doesn't the monsoon develop evenly at every place? It does not develop evenly at every place. That is because wherever we see a shift of ITCZ, only in those places we can see the monsoon to be strong. If there is less shift, there will be less monsoon in those regions. This was concept of Flohan. But there were certain things that were still not answered. See, this is the shift of ITCZ that is clearly here. You can see normally it takes place along the equator. It should be here. But once the summers are in, let's say 21st June, the sun is on Tropic of Cancer. This is the ITCZ, the pink line. It shifts northwards over India. Once we have winters, this ITCZ goes to the south because then the sun will be over Tropic of Capricorn. And the winds, this ITCZ will shift like this and go to the south. It will be over Australia. This is the shifting of ITCZ that attracts winds. Once we have summers, the winds will come from all the directions like this, then go to India, come like this and then turn towards India. In winters, the winds will come from these regions and go towards this. Are you getting my point? This is the concept of ITCZ. But there is one more theory, that is Yin's jet stream theory. This is again something that you can easily understand from our first class. How? That's what I'm going to tell you. Listen to me very carefully. You need to come back here. I told you about the shifting of pressure belts, right? Listen to me very carefully. Normally, what happens is we have three cells. Halley cell, Ferrel cell and polar cell. In my second class, I told you about jet streams, subtropical jet stream, if you remember. Subtropical jet stream develops here between these two cells, Halley cell and Ferrel cell. If you remember, I have explained you everything, how it develops, why it develops, but it develops at this place, between these two pressure belts. Now tell me, I just explained to you the shifting of pressure belts. This is 0 degree. Since the entire pressure belt has shifted northwards. Okay, entire pressure belt has shifted slightly northwards. The jet stream, what will happen to jet stream? What do you think? The jet stream that earlier was present here will now also shift northwards. Why? Because the entire pressure belts have shifted northwards. That will lead to the shift of the jet stream as well to the north. That means, if you take a look at this image, the jet stream that starts from this place during winters and early summers or spring season, it comes towards India. When it reaches near the Himalayas, since Himalayas are very high, it gets bifurcated into two branches. One is the northern branch of the jet stream that passes over India. This is India. This is India. Okay. This is India. It passes over India, so it causes no impact on Indian weather. But the southern branch, because it bifurcates, just imagine, no? We have Himalayas somewhere here like this. Okay. When the jet stream comes to India, it hits the Himalayas, it gets divided into two branches. One goes to the south and one goes to north. The north one doesn't concern us. The southern branch establishes itself over North India. Delhi, UP, even up to, in extreme cases, it was seen meandering as far as south up to Nagpur. So it covers the entire North India. Since this is a high pressure condition, it does not allow the winds to come from this region. Just imagine, look at me, look at me, look at my hands. Again, the basic example. This hand wants to go up. This hand wants to go up. But there is already a pressure system that's exerting pressure. It is not allowing the hand to go up. Same is the case here. There is already high pressure system due to this subtropical westerly jet. So it is not allowing the winds to come to north. During summers, what happens is that since the entire pressure belts shift to the north, the jet stream also shifts northwards. In the earlier image, you saw how the jet stream ideally would hit these mountains and one branch will come towards south over the northern India. But now the pressure belts have shifted to the north. I know this might be confusing, you can tell me in the comments, but this is very interesting if you understand. Now, since all the pressure belts have shifted to north, this jet stream will also shift north and it will not strike the Himalayas, so it will pass from above. So the high pressure system that was earlier developed is absent. It disappears. The southern branch will disappear and the high pressure system will end. So there will not be high pressure system and the winds will now be easily able to come towards India. This was the concept that explained the break of monsoon. Why is there the sudden burst of monsoon? Why is there the sudden burst of monsoon was clearly explained by this theory. How? How? What do you think? How did it explain the sudden burst of the monsoon? Listen to me carefully. What happens during the summer season is in the month of, let's say, March, April, May, there's intense heating of Indian landmass. Intense heating causes the development of low pressure pockets in India. Low pressure cells start to develop. But due to the presence of southern branch of the jet stream, these winds are still not able to come towards India. But once the branch disappears, once this branch totally disappears, and the low pressure pockets are already present, all of a sudden, just imagine, look at me, look at my hands, the high pressure system is stopping everything. Assume that all of a sudden this disappears, the high pressure disappears, it will all of a sudden come towards India. So this leads to the burst of monsoon. So this was the jet stream theory that explained the burst of monsoon. This was the important theory. And finally, we come to the last theory, that is Koteswaram's theory of monsoon. What is this theory saying? Have you ever thought that there is a shift of ITCZ throughout the world? We can see monsoon rainfall at multiple places. But why we are more concerned about monsoon in India? The impact of monsoon in India is way too much pronounced as compared to any other part in the world. That is why Koteswaram studied monsoon and tried to establish the connection between the monsoon and India. Why is it so? And then he figured out the role of Tibetan Plateau. The role of Tibetan Plateau is very important in monsoon. And this also determines whether there will be a delay in monsoon or early onset of monsoon, strong monsoon, weak monsoon, everything. How? Listen to me very carefully. Look at this map. This is Tibet, a vast land. What happens is this is at a height of 4,000 meters. When the land heats up, because this is a plateau, then we have Himalayas after this and then India. When this land heats, the air starts to rise because this is very high. The height is 4,000 meters, so the solar insolation will be more. More the height, more the solar insolation. So the land mass will start to heat and the air will start to rise. Now you might ask me a question, sir, okay, we agree, this is a height of 4,000 meters, it heats up. But Himalayas are 8,000, sometimes 8,800. Why don't they heat up? The thing is that Himalayas are not flat. If the peaks heat up, the winds will start to blow. This is the concept of anabatic and katabatic winds. Separate topic. We will learn it when we reach there. Right now, we need to focus on something else. When the Tibetan Plateau will heat up, the winds will start to rise here. Okay? The winds will start to rise. This is the Tibetan Plateau. Okay? These are the Himalayas, Greater Himalaya, Lesser Himalaya, Shivaliks. Then we have Indian land masses. Okay. Then we have water body, Indian Ocean, Arabian Sea. Finally, we have south where we have Madagascar, Mascarenes High. Now, what happens during this time is that when the sun heats this Tibetan plateau, the air heats up and it starts to rise. Once it reaches to a certain height, at a certain height, it starts to diverge. One branch will blow in this direction, one branch will blow in this direction. This branch that starts over India and starts to blow over India couples with the high pressure condition at Mascarenes High. Okay, and it will start to sink at Mascarenes. I'll show you on a map what I'm talking about. Look at this. This is the Tibetan Plateau where the air rises up, then starts to travel. One branch will start to come towards this region and eventually settles down at Mascarenes High. Clear? This increases the high pressure conditions on the Mascarenes. So that is how the Tibetan Plateau plays its role. Two reasons that impact the monsoon are: number one, the high pressure conditions increase at Mascarenes. If the conditions are high, if the high pressure is here, what's going to happen? India already has low pressure due to high temperature. So it will attract more winds. More winds will start to blow towards India. Number one. Number two, the second thing is about the tropical easterly jet. Once the air will rise, what will happen is it will start to move like this over India. We have equator here. Why is the wind moving like this? Because in the northern hemisphere, it will be turned towards right. It will be turned towards right. So the winds will start to move like this. They reach the equator and then they will be turned towards left. And eventually they will sink near the Mascarenes at this very region. They will sink here at Mascarenes. And this is the direction and is the easterly jet. This is a temporary jet that I mentioned when we were discussing about the jet streams. This is known as tropical easterly jet. This also impacts the monsoon. How does it impact? Second one is the tropical easterly jet. How does it impact the monsoon? Imagine a wind blowing very fast in the upper atmosphere. It creates a sort of a vacuum in the upper atmosphere. Fast flowing wind. Sir, how does the wind blowing fast create a vacuum? You do one experiment at your home. You take two balloons, place them. When you place the balloons, then move your hand very quickly between the two. This is one balloon, this is second balloon. Look at my hands. One balloon, second balloon. Then move your hand like this, quickly. What's going to happen? The balloons will come towards each other. You do this observation at your home. The pressure system falls because the hand moves quickly in between. The balloons will come towards each other. A low pressure condition is created between the two balloons. The same thing applies here as well. The same thing will apply here as well. When you take a look at this, when you move your hand quickly, the balloons will come towards each other. They will start to move towards each other. Similarly, when the jet stream that starts from here, this image is not correct. The winds move somewhat like this. Okay, then they go here. They create a kind of a vacuum which attracts more air, more convection and more rainfall. And second, I told you, once the winds start to blow, they will settle over Mascarenes High. What will it do? A high pressure condition will be created here. In India, due to high temperature, we have low pressure conditions. So the winds will start to blow from high pressure towards low pressure. That leads to monsoon. So the role of Tibetan Plateau is very essential. It is very essential as far as the monsoon is concerned. And that is why this region, Indian Ocean region, is predominantly known for its monsoon type of climate. although the monsoon is present in other places, but it's not as dominating as it is in this very region. In fact, there's one more associated term, that's Somali jet. Okay, what happens is once the winds start to blow from this region, let me just, this is unfortunately not very clear map. I will try to draw a map here. This is Africa. This is Africa, not India. Huh? My drawing is bad. This is Horn of Africa. And then we will take a look at India. India is somewhere here. This is the equator. Okay. What happens is, this is Mascarenes High. This is Mascarenes High. When the winds start to blow in the southern hemisphere, what will happen is the winds will come and blow in the left direction. Okay. Once they cross the equator, they will turn right. The winds will cross the equator and turn right and come towards India. This is the region known as Somalia. This is a country called Somalia. From this region, the winds will start to blow towards India, and these are low-level jets known as Somali jet. If the conditions in this ocean are warm, comparatively warm, these winds will carry more moisture, cause heavy rainfall. If the conditions are not warm, then there will be less rainfall. That is again the concept of Indian Ocean Dipole. We are going to learn about them, maybe in the next class, but for sure. So these are some of the factors that are responsible for rainfall. Now we get back to our main question. Why was there a delay in monsoon this year? Why was there a delay in monsoon this year? What do you think? Listen to me very carefully. Two conditions that are very important are the ocean temperatures, number one, and number two is the ENSO condition. ENSO condition. This includes the El Nino, La Nina. This we will have to discuss in a bit more detail because 2026 is a year of super El Nino. This is something that happens once in a while. It doesn't happen every now and then. So 2026 is a super El Nino year. So there's a very good chance this might be asked in your exam. 2026 is a super El Nino year. Right now, the other reason that is responsible for weak monsoon is the ocean temperature. Okay, how does ocean temperature impact the rainfall? Look at this image carefully. If the ocean temperature is warm enough, then there will be evaporation. There will be evaporation. The winds coming from southern hemisphere will take the moisture along with them and cause rains in India. If the ocean temperature is less, if it is not that warm, then what will happen? The winds will come from the southern hemisphere, but there will be less moisture available. So when they will hit India, there will be less rainfall or no rain. If the moisture is too little, then there is less chances of rainfall. And that is exactly what the satellite data predict this year. Look at this image. This is the image of 1st June 2025. This is the image of 1st June 2026. Tell me something. Can you see the difference? The red color shows the temperature. The slight reddish color that is present here shows the temperature of the water. Are you getting my point? In 2025, at the same time, the temperature was more. If it's more red, that means the temperature is more. The temperature was more. So when the wind started from this region, because of high temperature, there was more availability of moisture. So they carried the moisture to India and there was rainfall. But when we look this year, look at this very region. Hardly any red region here. As compared to 25, too much of red region. In 2026, there is very little red region, or the temperatures are very less. The winds will come from this region, but they will not be able to carry moisture because there is less availability of moisture. This is a satellite image that's taken exactly at the same date as the last year. And you can see the variations in the sea surface temperatures. So that tells us why the winds are not able to cause rainfall. Of course, there is one more reason, that is El Nino. We will discuss that as well, but not today. That will take a lot of time. We will take time and then discuss that in detail. But right now, what you have to understand is this is something very important. Of course, the Arabian Sea is also an important role. Arabian Sea is not that warm, but Indian Ocean primarily is less warm, which eventually led to a less, or we can say a delayed monsoon in 2026. This is the map of India that talks of the Southwest Monsoon as of 2026. If you look at this line here, May 30 to June 3rd, you can see there is no rainfall at all because the line does not come to India. And when is the line coming to India? This is the line, June 4 is the line that shows exactly how the rainfall came to India on 4th of June. As I told you in the beginning of the lecture, June 4 is the date when we witnessed monsoon this year. So there was delay. Yes, there was delay. And this is the map that shows the progress of monsoon further. Now, there is one very important thing that you need to understand. Despite of the fact that the monsoon came late, it is still progressing. It comes late, but doesn't mean that it will not go ahead. It is going ahead. It's causing rainfall in Mumbai, in Goa, and even in Delhi as of now, the date on which I am recording this class. In today's date, we see the rainfall in Delhi as well. So it has eventually progressed through and gone to entire India. But the matter of the fact is that there is a slight delay because of less moisture availability, because of strong El Nino. And that is why I gave you 3 criteria that determine whether the rainfall is monsoon or not. Why? Because this year there's a delayed monsoon. So you can easily get a question in your mains that how can we predict a delay of monsoon? How can we say that the monsoon is delayed? How can we differentiate between any other normal rain or monsoon rain? You have to write these criteria. You have to explain them that this is one thing, 2.5 mm of rainfall, 14 these sectors. Then we have the second criteria, that's wind speed, and the third criteria is outgoing long wave radiation. These 3 criteria you need to explain, and of course with that you need to explain the sea surface temperature. One important thing that we are left with right now is ENSO. This is a separate topic because this is also too much important this year, because this is in news, and the next topic that we're going to discuss in the next class will be ENSO. There are some other factors as well that are responsible, in which we have Indian Ocean Dipole, Madden-Julian Oscillation, so on and so forth. But these are some of the things that we will discuss in the coming lectures. For today, I think that's all from my side. Today we will stick to this much. You revise this, and if you have any confusion, any question, kindly let me know in the comments. Drop your queries and I will get back to you in the next classes or in the comments as well. Till then, bye bye, see you next time.